Hello, nice to meet you everyone. Now I want to explain a little much ways how to prove Pythagorean theorem. But before it, it's better if I introduce myself. My name is Ephi Tampubolon. I am from University of Jakarta and majoring at mathematics education. And this time I will explain proof of Pythagorean theorem. Actually, there are so many ways to prove Pythagorean theorem, but in this time I choose 4 ways to prove that Pythagorean theorem. The first is proof with algebra, the second is Pythagoras is proof, the third is Garfield is proof, and the fourth is proof by similar triangle. Okay, we will start it from the definition of Pythagorean theorem. The definition of Pythagorean theorem is the well-known geometric theorem that the sum of the squares on the legs of a rectangle is equals to the square on the Pythagoras, or the side opposite the right angle, or in familiar algebraic notation is a square plus b square equal to c square. The first is proof with algebra. In this picture, we can see a square with side a plus b. Inside the square, we see there are 4 triangles that are congruent and 1 square with side c. Area of whole square with side a plus b is a plus b square, while area of the pieces are first small square with side c. The area is c square. The second is area of 4 triangles that are congruent. We just need to review a right triangle. We know that area of a right triangle is a half of product between the height and the base. So in this case, because there are 4 triangles, the sum of the area is 4 times a half of product between base and height. We simplify it, so we find that the area of the 4 triangles is 2AB. We know that area of whole square with side a plus b is equal to the sum of the pieces area inside that square. So we can write it in notation as a plus b square equals to c square plus 2ab. We expand the equation a plus b square to be a square plus 2ab plus b square. A square plus 2ab plus b square equal to c square plus 2ab. We move the 2ab in right side to left side, so the sign will be changed to be a minus. So we find a square plus b square plus 2ab minus 2ab equals to c square. 2ab minus 2ab is finished. So the final notation is a square plus b square equal to c square. The theorem is proven. The second way is by Pythagoras is proof. In these ways, we need to square to prove Pythagorean theorem. The first square with side a plus b contains 6 parts. They are: first, a square with side a; second, a square with side b; and 4 congruent triangle with base A and height B. The second square, we find 5 parts. They are 4 triangle with base A and height B, and a square with side C. Area of square 1 is the sum of the square with side A and the square with side B, and 4 times a right triangle. So area of square 1 is a square plus b square plus 4 times 1 over 2ab, while area of square 2 is the sum of 4 right triangle plus area of a square with side c. So area of square 2 is c square plus 4 times 1 over 2ab. From this picture, we know that area of square 1 equal to the area of square 2. So, a square plus b square plus 4 times 1 over 2ab equals to c square plus 4 times 1 over 2ab. 4 times 1 over 2ab in right side, we move to the left side. so the sign will be changed to be a minus. So a square plus b square plus 4 times 1 over 2ab minus 4 times 1 over 2ab equals to c square. So the final notation is a square plus b square equals to c square. The theorem is proven. The third way is Garfield is proof. But before that, we want to know who is Garfield. Garfield, with the full name James Abram Garfield, is the 20th President of the United States. He gave the following proof to the Pythagorean Theorem. He discovered this proof 5 years before he became a president. He hit upon this proof in 1876 during a mathematics discussion with some of the members of the Congress. The proof depends on calculating the area of a right trapezoid in two different ways. The first way is by using the area formula of a trapezoid, and the second is by summing up the areas of the three right triangles that can be constructed in the trapezoid. He used the following trapezoid in developing his proof. In this picture, we can see there is a right trapezoid, and inside the right trapezoid there are three right triangles. The formula for the area of a trapezoid we know is a half of product between height with parallel side. In this case, area of our trapezoid is 1 over 2 times a plus b times a plus b, or we simplify it as 1 over 2 times a square plus 2ab plus b square. Area of trapezoid equal to the sum of three right triangles inside that trapezoid. We know that area of the right triangle is 1 over 2 times base times height. In this case, there are two congruent triangles with base A and height B. So the area is 2 times 1 over 2ab. Then we get equation that is 1 over 2 times a square plus 2ab plus b square equals to 2 times 1 over 2ab plus 1 over 2c square. So we multiply the both sides with 2. Then we get a square plus 2ab plus b square equals to 2ab plus c square. We move the 2ab from the right side to left side, so the sign will change to a minus. So a square plus 2ab plus b square minus 2ab equals to c square. So the final notation is a square plus b square equal to c square. The theorem is proven. The last way in this material is proved by similar triangle. In this case, actually we just draw a right triangle, but we need to draw a height line from the right triangle. So we will get three similar triangles. The first triangle is that wall triangle with base B and height A, while the second triangle is with base F and with height D. The third triangle is with base E and the height is F. From the ratio similarity of triangle, we found that A over D equal to C over A. We found that A over D equals to C over A. Then we simplify it as A square equals to C times D. While ratio similarity between the first triangle and the third triangle, we found that B over E equals to C over B. We simplify it as B square equals to C times E. We sum A square plus B square. So we find A square plus B square is equal to C times D plus C times E. We move out the C from the brackets, so we find A square plus B square equals to C times D plus E. So we know that D plus E equals to C. So A square plus B square equals to C times C. Then the final notation is A square plus B square equals to C square. The theorem is proven. Okay, until here my explanation about how to prove Pythagorean theorem. And I say thank you because you watching this video, and thank you to Memelia Sari because from this final assignment I can improve my skill English language. Thank you for watching. Goodbye.